Picture this. You are sitting inside a spacecraft, looking through a small porthole window as Earth shrinks behind you. Not for days. Not for weeks. For years. The blue gets smaller, then dimmer. Then it disappears entirely into a field of stars that all look the same. You are heading to Uranus, nearly 3 billion kilometers away. A world with no ground to stand on, no air to breathe, and winds that would tear a building apart before the building even knew what hit it. And here is the part nobody tells you before you leave. By the time you get there, your body will already be broken. Your bones will be hollow. Your heart will have shrunk. Your brain will carry damage that no amount of recovery time will fully reverse. And turning around to come home won't save you. Because the journey back will finish what the journey there started. This is not science fiction. This is the physics of what space does to the human body over time, and Uranus sits so far beyond what our biology can endure that sending a human there isn't an engineering challenge. It's a death sentence with a very long delay. This is Michael Alex, and you are watching Vortex, where we follow the science honestly, even when it leads somewhere uncomfortable. Let's talk about Uranus. Uranus is not far in the way people casually use that word. Mars at its closest sits roughly 55 million kilometers from Earth. People discuss a Mars mission like it's difficult but achievable. Uranus at its closest is still approximately 2.6 billion kilometers away. Not 50% further than Mars. 50 times further. Voyager 2, launched in 1977, used a rare planetary alignment that repeats every 175 years, slingshot past Jupiter and Saturn, and still took 8 years and 5 months to reach Uranus. That was a lightweight unmanned probe with no crew, no food, no life support systems whatsoever. A crewed spacecraft changes the calculation entirely. Add oxygen recycling, water filtration, years of food supplies, medical equipment, and enough fuel for orbital corrections. All that mass slows everything down. Realistic estimates for a human mission to Uranus land between 12 and 15 years one way. 12 to 15 years inside a metal container. No open sky. No seasons. No fresh air. No ground beneath your feet. And while you sit in that silence, the first enemy is already working. Invisible, odorless, completely unstoppable. Beyond Earth's magnetic field, galactic cosmic rays flood through the spacecraft constantly. On Earth, our atmosphere blocks 99.9% of this radiation. In deep space, there is nothing between you and it. NASA's career radiation limit corresponds to roughly a 3% increase in fatal cancer risk. A Uranus mission would exceed that limit many times over, and unlike most threats, the damage is permanent. It breaks DNA, accelerates cardiovascular aging, erodes cognitive function, and dismantles the immune system from the inside out. Every year of travel adds to a total your body cannot subtract from. Radiation is the invisible enemy. Weightlessness is the slow one. On Earth, gravity makes constant demands on the body. Bones stay dense because they carry load continuously. Muscles stay functional because they work against gravitational resistance every moment of every day. The heart pumps blood upward against the pull of an entire planet. Every biological system is calibrated to 9.8 meters per second squared, and that calibration took millions of years of evolution to build. Remove gravity and the body immediately begins releasing what it no longer needs. Astronauts on the ISS lose between 1 and 2% of their bone mass every single month. After 6 months in space, they return to Earth needing weeks of intensive rehabilitation just to walk normally. Some never fully recover their original bone density. And those astronauts exercise 2 hours every day using specialized resistance equipment designed specifically to slow this process. They still lose bone. Now extend that to 15 years. After 5 years in weightlessness, the skeleton begins resembling severe late-stage osteoporosis. After a decade, the bones that once held a person upright could fracture under their own body weight simply from the act of standing on a planetary surface. The heart follows the same path. Studies show it can lose up to 20% of its mass during extended missions because it no longer pumps against gravitational load. Blood volume drops. The cardiovascular system restructures itself entirely for a weightless world. After 6 months, many returning astronauts faint trying to stand. After 15 years, the heart would not just struggle under Earth's gravity. It would be physiologically incompatible with it. So let's say you survive the journey. 15 years of radiation exposure. 15 years of weightlessness dismantling your skeleton and cardiovascular system. Over a decade of psychological erosion sealed inside a metal container where a radio signal takes 2.5 hours just to reach Earth. You arrive at Uranus. And it offers nothing. Uranus has no surface. Beneath the atmosphere there is no ground, no rock, no place to land anything. The interior is a pressurized ocean of water, methane, and ammonia compressed to conditions that would crush and heat any structure we could build until it simply stopped existing. NASA has stated explicitly that extreme pressures and temperatures would destroy a descending metal spacecraft. Cloud top temperatures reach -224 degrees Celsius, the coldest planetary atmosphere in the solar system, colder even than Neptune, which orbits 1 billion kilometers further from the Sun. The atmosphere is 83% hydrogen, 15% helium, 2% methane with traces of hydrogen sulfide, the chemical responsible for the smell of rotten eggs. Wind speeds reach 900 kilometers per hour. Earth's strongest hurricanes peak at 300 and flatten entire cities. Then there is the tilt. Uranus rotates at a 98-degree axial tilt, rolling around the Sun on its side after a collision with an Earth-sized object billions of years ago. Each pole endures 42 consecutive years of direct sunlight, then 42 consecutive years of complete darkness. The magnetic field adds a final layer of chaos, offset from the planet's center, tilted 60 degrees from the rotational axis, an opening to solar wind bombardment every 17 hours. There is nothing here a human being can use. Here is the cruelest part. Even if you survived the journey there, even if you somehow orbited Uranus safely without descending into the atmosphere that would crush you, even if you completed every scientific objective that justified leaving Earth in the first place, turning around and going home would not save you. The return journey takes another 12 to 15 years. Total mission time, 25 to 30 years in space. By the time that spacecraft re-entered Earth's atmosphere, the people inside would be physiologically unrecognizable. Bones hollow beyond repair. A cardiovascular system rebuilt for weightlessness and incapable of functioning under normal gravity. Muscles largely gone. Brain tissue carrying decades of accumulated radiation damage. Immune system fundamentally compromised. Stepping onto Earth's surface might kill them. Not metaphorically. The gravity that every human body is built for would be the thing that finished them after the journey home. We have sent exactly one spacecraft to Uranus. Voyager 2 flew past in January 1986 and gathered most of its data in just 6 hours before continuing outward. That brief encounter remains the only close observation ever made. In 2022, the Planetary Science Decadal Survey named a Uranus orbiter and probe mission as the top scientific priority for the coming decade. That mission will be robotic. Because we now understand where the limits are. Mars sits at the edge of what we might attempt with humans. Uranus is not beyond that edge. It exists in a completely different category. We are products of this planet, every bone, every heartbeat calibrated by millions of years of evolution to Earth-specific conditions. Take us away long enough and that calibration fails permanently. Uranus will keep its secrets a little longer. Not because we cannot reach it, but because reaching it with human hands would cost us the very thing that makes those hands worth sending. If this changed how you think about the limits of human exploration, this video did exactly what it was meant to do. Hit like before you leave. It costs you nothing, but it tells the algorithm this content deserves a wider audience. Every single like puts this in front of someone who has never thought about what space actually does to the human body. And if Vortex is the channel that gives you the honest version of the universe, subscribe. We are building a community of people who want real science, not the comfortable version of it. See you in the next one.